We've managed to touch the sun. When I say we, I mean NASA's Parker Solar Probe. And by touched, I mean that the spacecraft entered the outer layer of our star, and the spacecraft survived. That happened in April 2021, but scientists told the world about the touchdown only in late December. The whole initiative is not about adding a new achievement to the list. The probe's task is to thoroughly study how the sun works to help us better predict its destructive flares. And our brave scout has already spotted something extraordinary. In this video, you'll get answers to these questions. Why does the solar wind sometimes blow in the opposite direction? What other weird things will our probe find inside the sun? Could we survive an impending solar hurricane in the next few years? And what other dangerous anomalies can stars be hiding? What weird things did Parker's solar probe notice after touching the sun? In fact, our star functions in a simple way. Hydrogen in its core turns into helium and puts out energy. Fuel consumption is 700 billion tons per second, which equals the mass of 100,000 Egyptian Great Pyramids. There's a catch, though. The sun emits its energy unevenly. A coronal mass ejection is the most terrible anomalous flare. If it hits Earth, it can disable all our electronic devices. And we don't know how to predict these emissions, since we can't see that side of the star where they occur from our planet. The sun's corona is its outermost layer, and it can be seen only during an eclipse. The corona was exactly where the Parker Solar Probe dived into and captured plasma flows, whose temperature reaches 833,000 degrees. However, the spacecraft soon exited this zone, although it never abandoned its course. That's because the stellar corona isn't really a sphere and has an abnormal shape. It makes the sun look more like a dented golf ball. Parker's solar probe flew through a couple of similar space bumps and found another anomaly: switchbacks of the solar wind. Particle beams suddenly turn towards the sun just to turn back again soon and fly away. It's very similar to a shockwave that moves toward the end of a whip. But how does the sun do this trick? All the answers lie below the surface. What will the probe see inside our sun? Unfortunately, the spacecraft will need more than just one carbon heat shield for a plunge like that. Let's upgrade the probe by placing it in a protective warp bubble. Now it's safe to plunge. When we move past the corona and farther down, the air around will get a bit colder. In the photosphere, our thermometer will show only 2,200 degrees. Scientists struggled to explain why there's such a big temperature swing. The probe will also see gorgeous solar granules. The smallest of these cells is the size of Texas. Their borders are precisely where such anomalies as switchbacks of the solar wind occur. Heated plasma gets here from the convection zone. This is a layer of the sun which is 200,000 kilometers thick. This is also a place where matter is constantly mixed, just like boiling water in a pot. However, pressure below the convection zone is so high that plasma can no longer move there. This is a radiation zone. Hydrogen atoms are packed so closely here that they can only exchange photons. It's as if players pitched baseballs and never left the bases. What's more, the balls can be thrown in any direction. That's why a photon can be zigzagging towards the sun's surface for thousands of years. Now, it turns out that the sunlight we see today had been born long before the Great Pyramids were built. It originated in the core, where hydrogen turns into helium at a temperature of 8,330,000 degrees. And the point is that some scientists believe that there may exist anomalous forms of life in such hellish conditions. Physicists at the City University of New York have come up with a somewhat crazy theory. They think that inside stars, there may exist organisms whose DNA is composed of charged particles of plasma. Creatures like that could possibly feed on the energy released by nuclear reactions, which could explain some stars' abnormal luminosity swings. So, shall we send our probe there? How do stars that differ from the sun work? and what anomalies can be found there. Our closest neighbor is Proxima Centauri, a red dwarf. Stars like that are usually 10 times smaller than the Sun and way colder. Their surfaces reach 2,000 degrees Celsius. The inner space of this star is almost entirely occupied by a conventional zone where both hydrogen and helium circulate. Speaking of the Sun, virtually all its helium is kept in its core. The red dwarf's low weight leads to an anomaly. It has no radiation zone at all, so photons have nowhere to roam around for thousands of years. Plasma gets thoroughly mixed even in its core, which is the size of a Jupiter-like planet, and it's just 2 times hotter than here on the surface. The red dwarf doesn't shine bright, but it shines long, perhaps for trillions of years. But what if we dive into a big star? Into Sirius A, for example. It's also situated not far from us, and it's 2 times heavier than the Sun. This blue and white star is 25 times brighter than ours, and its surface is 1.5 times hotter. But what is it? Below the photosphere, we'll immediately bump into the radiation zone with its bouncing photons. And when it comes to the Sun, this zone is much deeper. On the contrary, below it there's a convection zone where the plasma gets mixed. The white and blue stars emit so much energy that they get literally turned inside out. They don't know the art of rational spending, so they burn out dozens of times faster than a yellow star like our Sun. As a result, the only thing left of them is the core. These stars are the most anomalous places for diving. What unusual things will the probe find inside these stellar corpses? Most of them are white dwarfs. This dull sphere is the size of Earth, but its mass almost equals that of the Sun, and its surface is unbelievably hot, 100,000 degrees Celsius. The heat clearly comes not from the hydrogen and helium residues that cover the upper 10 kilometers of the star. The probe meets a core composed of a very strange substance when it moves down. This is a sphere made of highly compressed subatomic particles, protons, neutrons, and electrons, almost like a junkyard. There are no nuclear reactions. The white dwarf just cools down for billions of years. The massive star turns into an even more exotic corpse. A neutron star is no more than 15 kilometers in diameter, and its temperature reaches 1,000,000 degrees. First, the probe will touch the finger-thick atmosphere of hydrogen and helium. Then it will get to the outer crust, composed of subatomic particles, the same as the white dwarf's core. Entering the second layer of the crust, we're greeted by a thick neutron soup. So thick that a spoonful of such soup weighs as much as 20 Great Pyramids. In the core of a neutron star, our conventional laws of physics seem to be no longer relevant. We just don't know what's happening in this anomalous zone. Anyway, given such intense gravity, even our protective bubble will implode, and then the probe will melt inside this strange star. Perhaps it'll be saved by some even stranger interstellar form of life. I wonder what these aliens would think about our probe. I guess if someone told those guys that the spacecraft was sent by intelligent beings living on small planets beyond the stars, they would consider it a wild conspiracy theory. But what we can surely agree with them on is that all stars sometimes turn into killers. In early March, the year 2021, scientists first noticed a space hurricane with electron rainfall in the Earth's ionosphere. They managed to observe a swirling mass of plasma 1,000 kilometers wide above the North Pole. According to their calculations, it predicts that in the year 2025, the Earth may be overtaken by an even more powerful space hurricane. NASA says there's no way to escape it. What if it turns out to be true? In that case, in this video, I'll help you make a list of basic supplies for survival in a space hurricane and share a secret place that might serve you as a shelter. Has mankind ever experienced anything like this? For the first time, scientists have discovered a space hurricane of plasma in the Earth's upper atmosphere on the 20th of August, 2014. By the way, The USA celebrates National Lemonade Day on that day. People didn't notice any extremely unusual events. That space hurricane passed unnoticed. But if it can't distract us from a glass of lemonade, then why should we fear the hurricane of 2025? If lemonade can be overdone with syrups, a space hurricane can be overdone with coronal mass ejections. It's all about solar flares. During normal solar activity, their ejection moves towards the Earth in the form of a large number of charged particles. They reach the Earth within 2 to 4 whole days, and most of them, fortunately, keep the Earth's magnetic field in the upper atmosphere. If it weren't for that protection, that superflare would have led us to an environmental disaster, burned the forests, and exposed every living thing to harmful UV radiation. But an increased charged particle burst would be fatal to electronics. It first happened in 1921. Astronomers observed a huge sunspot with a radius of about 150,000 kilometers. A geomagnetic storm disabled half of the New York Central Railroad equipment and left almost the entire east coast of the United States without communication. This event was called the Railroad Storm. Let me remind you that this is just usual solar activity. In 2025, it's expected to reach its peak, and the consequences will be dire. Because compared to the early 20th century, we're a lot more dependent on electronics. Trains will break off. Traffic lights will stop working in the streets. Complete chaos in the transport system. You won't be able to call your grandfather on WhatsApp to ask how he's feeling. Now, to communicate, you'll have to pay a visit. So, the first thing to put on your Survival 2025 list is a bike. It will help solve the problem with both getting around and communication. How powerful can solar storms be? There's one thing in the solar ejection that even our planet's protective shield cannot always defend us from, and this is the electromagnetic field of charged particles. You'll not be able to finish cooking a soft-boiled egg, as the electric stove, light, and any other equipment will turn off. The power of solar storms is equal to the energy that our entire civilization could consume within 1,000,000 years. Overvoltage damage to the stove or fridge is the smallest part of the disastrous consequences. The geomagnetic storm of 1989, called the Quebec Power Blackout, caused extensive disruptions in the energy system of the Canadian province of Quebec. It disrupted high-frequency radio links around the world and destroyed an electrical transformer at the Salem nuclear power plant. The only good news is that during the storm, the most beautiful northern lights were observed to the latitude of Mexico and Grand Cayman. Imagine that your house collapsed, but a rainbow appeared over it. People experienced the same mixed emotions that day. Therefore, if you're a romantic, add binoculars to the list. You'd be more comfortable observing a full range of colors the sky will prepare for you on the eve of the apocalypse. But first of all, think about what you'll eat so as not to die. You wouldn't be able to microwave a lasagna from the supermarket anymore. Without electricity, food will get spoiled in heated refrigerators very quickly. Add canned food and baby food to the survival list. Even if you don't have children, this highly nutritious product will help you out a lot. You'll need firewood and matches to make a fire. Now you have barbecue every day. But what is waiting for us in 2025? The problem is that nobody takes the global space threat warning seriously. And there's nothing weird about that. Scientists have repeatedly made mistakes with predictions for the end of the world, starting with the Elenin comet in 2011 to collision with Nibiru in 2012. Both never happened. Caitlin Durkovich, a special assistant to the U.S. president, is frustrated with people thinking space weather is Hollywood fiction. Most scientists agree that worrisome developments are inevitable. Only the magnitude of the implications fluctuates, which depends on the power of solar flares. Maybe the sun will spare us, and the flares won't be that violent. But in the worst case, a space hurricane will run the sequence of events on Earth that will look kind of like this. The year 2025. You're quietly watching Netflix on your laptop. Suddenly, the video stops. You're nervously refreshing the page, and you see just an annoying pixel dino. You're turning the switch on, but there's no light. You want to call the relevant services, but all communications stopped as well. Confused, you go outside like many other people. While you're standing with a cold slice of pizza in your hand, something much worse is happening in the world. Electricity and water pumping stations have stopped working. But the worst part is that Space Hurricane has disabled the satellites, which means that military, scientific, and meteorological personnel will actually go blind. Aircraft will crash, going down on residential areas and highways with monster traffic jams. No matter how much money you have on your card, you won't be able to cash it because ATMs will stop working. You could withdraw cash right away and keep it under a mattress, but all security systems will also be disabled. Your security will be put at risk, robbery and looting will begin. Therefore, add a gun to your list so that you can stand up for yourself. What will the consequences be? The first month after electron rainfall, the power generated by solar panels and portable generators has been depleted. The energy of backup generators in health facilities has been spent on those most in need. The rest have to be treated with folk remedies. Before your smartphone is completely discharged, you've managed to redraw the last map you downloaded. 6 months after the event, the positioning accuracy of the GPS satellite network will start to drop, and soon it will be completely useless. You're taking a sketched map, a backpack with everything on the Survival 2025 list, a few bottles of water, and hit the road. It has become unsafe to remain in an unprotected house in a society where chaos reigns. 1 year after the event. To effectively explore the post-apocalyptic world, you'll need special equipment. There is one material that has become indispensable for science in the process of its development. It is glass. It's needed to create various lenses for microscopes and telescopes. Most likely, we'll draw from the experience of post-war reconstruction and recovery from natural disasters and cataclysms. How to make yourself as safe as possible. You may not believe all this because solar cycles are much more flexible than our Earth's time systems based on the sun, and scientists may not know about the next space hurricane until it happens. But if you take their warnings seriously, you hardly want to die from a plane crashing down on you. And you certainly don't want to experience all the chaos on a space hurricane day. Millionaires and politicians will definitely find a place to hide. And you won't have much luck finding a golden ticket in a chocolate bar to enter a secret government bunker. So what, if something happens, should we, ordinary people, do? I found a place that could serve as a refuge. And this is the underwater Öresund Bridge between Sweden and Denmark. Hidden underwater and with concrete columns, it's ideal for becoming a safe shelter. Also, there's plenty of space. Here are its coordinates. You may not need them, but if the end of the world scenario comes to pass, the world would need people to help recover technology, science, and society. If you're ready to undertake such a responsible mission, start packing your backpack. And tell us in the comments, what else can be added to the Survival 2025 selection?